My name is Marcos Iglesias, and I'm here to talk about React, D3, and the database ecosystem within the context of building React applications. I work as a senior software engineer at Eventbrite, building user interfaces and dashboards for our event organizers. You can find me online on Twitter, where I share resources about database, D3, React, web performance, and front-end technologies in general. I also manage Eventbrite's engineering blog, where you can read my posts and also my peers' posts about engineering and engineering culture. But let's see what brought you to this session today. React and D3 are two great user interface tools designed for goals that sometimes collide. The problem is that both take control of the DOM elements, and they do it in different ways. So, how can you make them work together, optimizing their features depending on your current project? In this talk, you will see how you can approach building React applications that need the powerful charting goodness of D3. Now let's see briefly the agenda for this session. We'll start talking a little bit about D3 and their libraries. Then we will talk about React, and we will review the different strategies to combine both libraries, as well as some libraries that are actually doing that already. Lastly, we will talk about choosing the best options for your projects and for your requirements. So let's start with D3. Can we do a small poll here? Who has worked with D3 before? Can you raise your hands? Okay, so maybe 20%, 30% of the room. Cool. So let's see, what is D3? D3 stands for Data-Driven Documents, and it is a low-level visualization library with a huge API. D3 manipulates data-based documents, and it's focused on mathematical transformations of data. It is also based in open web, so SVG, HTML, CSS, and Canvas. And one of its more celebrated features is its seamless integration of animations and interactions on the charts. In general, D3 is a front-end toolbox for creating interactive visualizations. And what it is not, it's a charting library. So D3, you won't find something like, okay, let's do a bar chart, and boom, it does it. No. D3 doesn't work like that, but we will see some libraries that actually allow you to do this. So, how does D3 work? In general, D3 loads data and attaches this data to the DOM. Then, it binds that data into DOM elements and transforms those elements, transitioning between states if necessary. Usually, the data is going to stay on the DOM because the idea of Mike Bostock, the creator of D3, was that the DOM was the most stable element in all these kind of front-end development thing. So let's see this working in this example. This is my favorite example. D3 maybe is kind of more emotional thing because my first project was doing something like this. This is the Obama administration budget proposal for 2013. It looks terrible here, but shouldn't. Let's see. There we go. Okay, this is from the New York Times. And basically, this is a bubble chart. In this bubble chart, each of these bubbles represent an entry for a budget. You see that there are different sizes. So this bigger the size of the bubble, it means that the budget is bigger. And you always see that they have different colors from kind of this green up to red. And the color represents the variance against last year. So if the budget is bigger, then it gets greener, and if it's smaller, then it gets red. So the transformation I was referring is about the sizes and the colors. So we have a data entry, we put the size depending on the size of the budget, and the color depending on the variance against last year. But this is not all. So if I go here and click on these buttons, I'm able to take in the same bubbles, the same data, the same elements, we're just moving them around. So I'm changing the location depending on different points of view. In this one, it's about the variation again. So you will see that the greener dots are on the top, the redder on the bottom. And then here, this one is by department. So what we are actually doing is we are saying, okay, everything that is on the Social Security department is going to try to go here. The good thing of D3 is that all these animations from one state to the other, all this is kind of for free. It's magic, basically. We're telling them, you get these bubbles, and we put it in the middle, and all this animation and this kind of gravity thing is already baked in. We don't have to do anything. Cool. So currently, we are in the version 5 of D3, but the change between the version 3 to the version 4 was a little bit harsh. Now, all D3 is made of submodules that are in different repos. So you can use those different pieces. You don't have to use the whole library at once. And also, the API got improved. And in some cases, that created some breaking changes. So things that were working before, they're not working anymore. However, good thing is that it was most of the people is already on D3 version 4 or version 5. There hasn't been a split like it happened with the Angular community, where a lot of people use Angular JS or Angular 1, and the rest are moving into the new versions. Cool. So it's important to talk about data joins when talking about D3. Maybe this is concept is a little bit hard to understand, and if you don't get it at the beginning, that's fine. It took me, I would say, years to understand it really well. But I'm going to touch them a little bit because we will talk about parallelism between the way that React works and D3 works. And the data joins is a big part of it. So a data join transforms the DOM by selecting elements and joining them with data. Thank you. So for doing this, we're going to use a module that's called D3 selections. And basically, all this data join thing is another way of managing the DOM. In the days of jQuery, we used to wrap DOM elements on jQuery and operate with them, right? Then later came the old Backbone and all the MV star frameworks that allows us to do to kind of render views and re-render them with different states to get our UI. Now, with React, what we do is we are getting smarter about how we render those views. And with D3, what we do, we have the data joins. Let's try to understand this with a diagram. So imagine that we have these elements on our DOM. So we have 5 elements, and we have A, B, C, D, and E. So that's the data, and that's what we are actually rendering on the DOM. Well, now imagine that we're going to create a data join. So we're going to say, we're going to get new data that is these letters, so Y, E, A, O, and I, and we're going to join it. We're going to create a data join, and these, it looks a little bit like this. So there will be some elements that were already there. So A and E, they were already there. So we keep them. And that we're going to put in this group that we call the update group. Then there are some elements, B, C, and D, that they are going to go. We don't need them anymore. So those are going to go into this exit group. And then we have Y, O, and I. There are new elements. So the new elements will go into this, what we call enter group. So at the end, what we're going to do is with these three different groups, we're going to do something different. And we're going to say what we want to do with them. So at the end, this is kind of like a diff algorithm, similar to what React does, but it's a little bit more modular. It's a little bit more in low level, so we can actually do different things. React, what it does is, okay, if it was there, we just don't re-render. If they're new, we render it, and if they're not, then we just remove them, right? So it's just render or not render. That's what React does. But in D3, we do more stuff, so it makes sense that it's a little bit more granular. Another way of seeing this is with this diagram. So we have data and elements on the DOM. So the elements that were on the DOM and that are in the new data, they stay on the update. The elements that were on the DOM but they are not in the new data, then they go into the exit group. And the new elements, they go into the enter group. In code, this transforms into an object that has 3 arrays, one for each of those groups. Cool. So now that we saw how D3 works, let's see how to organize your D3 code. The D3 community as a whole hasn't found a strategy or a standard way of creating components. Also, the most common of them is the Residual API. There is a pattern created by Mike Bostock, and that he shared in a blog post back in 2012. There are other people that try to approach it in a different way with an object-oriented approach, and there are a lot more ways, but we won't touch them today. I think the important thing here is that all the community on D3, we didn't agree on some way to create these components. Also, I've worked with D3 for a while, and almost work with tests. D3 is kind of hard, and there's a good chance that your first approach or your first implementation is not going to be the best. So it's really important to have being backed by tests, because that will allow you to refactor your code without a fear to break in it. Now, in the next section, I've done a small research of some of the best libraries based on D3. I have selected some that are well-tested and that are more or less in version 4 or above. And we're going to look at them from the point of view of their APIs. The first one is Plottable, which is a pretty popular collection of components to create data visualizations. Thinking about the Plottable API I'm going to put it up here because it's a really object-oriented library. What we will do is we will create instances of the different elements, and at some point we will compose them, creating a data visualization. Another modern library is Billboard. Billboard is a fork of a really popular D3 library called C3 that stopped being maintained, and somebody took over them and kind of put new modern tooling like Webpack and ES6, and now they're working with it and improving it a little bit. Billboard's API is more about JavaScript objects. So we're going to give to the charts, we're going to give an object, a JavaScript object, and that will define what that chart is going to look like. If you have ever worked with high charts, it's pretty similar to this. Also, among academic circles, a popular library is Vega. Vega takes that kind of declarative approach and goes a couple of steps further. Because with Vega, what you do is basically a JSON schema. You have a JSON file, and that specifies what the chart is going to look like. So we put it here, close to JavaScript objects. Another interesting library is D3FC. Its name stands for Functional Components for D3. This library wraps D3 components and allows them to modify the main selection from outside the chart. This is a pretty powerful feature that almost no library has. I will put it here, close to functional programming and also close to D3, in the sense that D3 is kind of a chain kind of way of building code. Lastly, I want to talk about bright charts, a library we created at Eventbrite and that we started 3 years ago from a refactor from some code that we have in production that wasn't really good looking. With Brightcharts, we wanted a library that could serve both D3 developers and non-D3 savvy developers. And the largest difference against the others is that it's a little bit more opinionated on the looks. API-wise, Brightcharts is situated more or less here. It's close to D3 FC, but a bit less granular. So it's a higher level. It's kind of, the components are bigger as well. So now that we talk about D3 and its libraries, it is the turn of React. So who has worked with React? Okay, so that's kind of all the room. Cool. So I'm going to go super fast about this one then, because you probably know what is React. So React is a JavaScript library to create user interfaces, and it's based on creating components. And in my opinion, that is what React brought to the table that is the best. It's a way of creating components that make sense. It is also really fast and performant on rendering. And a React component will keep track of the DOM, stay through its virtual DOM. It will update it with changes, and if necessary, it will re-render itself. Two essential elements of React is the reconciler and the renderer. Since version 0.14, they are separated. So we can use different renderers depending on your publishing target. So that could be, you can render on the web, native apps, or on VR. And here we can establish another similitude with D3, because with D3, you can also render in different formats. You can do SVGs, you can do HTML, and also you can do Canvas. React also had an update with React 16 and the Fiber architecture. Fiber is the new reconciliation algorithm for React. Before, React was batching DOM changes. But this new reconciler is superior because it takes into account priorities, schedules, and it can do parallel computations to keep the 60 frames per second refresh rate. So you can read an explanation of Fiber in this article by Lynn Clark. She makes it with some cartoons. It's a lot easier to follow because it's a little bit complicated in reality. A trait of React that I want to talk about is the use of dynamic child components when we use the library to render a list of elements. In these cases, we use unique keys for each descendant of the render component. This is more efficient as we avoid to render elements that they are already present in the DOM. So here you see how it's similar to D3 in the sense that React uses unique keys that you need to pass in, and they need to be unique. So usually you will use an ID if it's possible, right? Well, on D3, what it does is uses the data itself. But also, you can specify what part of the data you want to use as the key. So it happens that sometimes with D3 you do it, and you use the whole data, and it's kind of pretty similar, and it doesn't work as you will expect. So trying to put the unique keys there, it also helps. So basically, we have something super similar to what we have with dynamic child components on React. So you can learn more about the React reconciliation in this documentation page. I will share all these slides so you can access to the resources later. Cool. So up to now, we have talked about D3 and React on its own. We have reviewed their rendering processes and the last updates for each of the libraries. Next, we're going to see what do they have in common and the challenges that we will face when working with these projects. So, React and D3 are two libraries that share a common trait. They want to help us dealing with the DOM changes in an optimized way. in an optimized way. They both work in a stateless mode. That is, given an input, the render output will always produce the same result. Or at least they try. So we want to have pure functions. Sometimes it's not that easy, or sometimes you will just try to extract the non-pure part of it. But both libraries, they really love to do this. Regarding the challenges, D3 works with the DOM. And React keeps track of the DOM entirely. Also, they are both really opinionated libraries. And they were never meant to work together. So due to this, we have different approaches to integrate React and D3. And we can do it in all different levels, leaning more on the D3 or more on the React side. Let's gonna see them now. And we're gonna start with the D3 side, with the D3 within React strategy. So for the names of all these strategies, I just made them up. So maybe it's not gonna be consistent if you look for this name, but more or less the idea, I hope, is clear. Well, in this approach, we use React to render the chart container, and then we use D3 to draw the chart within the component did update lifecycle method. Then we will also need to block updates, hard-coding the suit component update to return false. With this approach, we give D3 all the power over the DOM. So we just create the container, and then we say to React, OK, up to here. Then D3 takes over. Let's see it, the code, how it looks like. So this is a super simple component. So we have a line. And then on component did mount, we will put all of our code that creates the chart. I'm sorry, here on the render, we're going to put a container, and we're going to use a ref to use it here as the root node. And then, again, on suit component update, we're just going to return false all the time. OK, so good things about this approach is that it works. And it works for a while. So it kind of works most of the time. And it's easier when the visualization is already implemented. So if you already have something on production that is a D3 chart, it's super easy for you to just copy that, put it on the component did mount, and you're done. But really, first, the problem is that it's not idiomatic on D3. It's really kind of, it feels extraneous inside a React component, but also it's a little bit nasty. So with this method, you end up with a file that has all the D3 code and all the React stuff all in one. And also, if your chart is not non-trivial, if you have a tooltip or if you have kind of support components, it's going to get big. It's going to get big. All your D3 code is going to be on the same function. It's not going to look good. But sometimes this is a good approach. The next strategy is React for DOM. That is a way of use existing D3 tooling but render it efficiently through React with the React ethos. So with this method, we're going to place a fake DOM that again is going to trick D3 so that D3 thinks that it's taking over the DOM, but it's actually not, because we're going to render the fake DOM with React. So it feels a little bit like a kind of a magician game or a trick. We'll see it on the code. So React for DOM works with an HOC. So here we have the HOC, and then we're going to use at the end, wrapping our component. And then on component did mount, we're going to get this Fox. This is the root node that we're going to use for rendering our chart. And then we're going to say, OK, it's a div. And then this is the prop that is going to be converted in. And here we do our D3 code, similar to what we have on D3 within React. And then what we do is we render this props chart. So chart, remember, we're setting it here. And this is what it is. It's pretty similar to the previous one, but it's using React for rendering. So the good thing is that we can use almost all the D3 API. And it's easy to integrate with database that we already have created. Now the good thing is that you have server-side rendering with this. So you could render this chart on the server and you will get the markup. I think that could be good or not is that you will need to use React animations. So you can use React Transition Group, React Motion Groups, or Resonance, or any of the myriad of animation libraries that React offers. The really bad things about this approach is that it's less performant, and so that it will be limited to a small and medium-sized database. And why? Well, it kind of feels normal, right? Because we have React that has a virtual DOM. And on top of this one, we're going to put another fake DOM on top of it, and then we're going to put D3 creating this chart. So it makes sense that this is not as performant as it should be, because we are kind of redoing the DOM 2 times, and also we are using the DOM 1. The limit of this, it will be something that I really cannot tell, and it will depend a lot on the charts that you are creating. Cool. Then this is my favorite approach. If you're used to React and want to have more structure on your D3 chart, this is, for me, an optimal approach. And this lifecycle methods mapping is based on a wrapper over the chart on D3. So we will have 2 files. One is the React component, and another one is the D3 file with the D3 chart. And basically, it's a facade. It's a facade design pattern. And we're going to have that D3 only file with create, update, and unmount. And then we will call those methods from our React component. Let's see it in code. So here, we have the React component. So on component div mount, we will have create an instance of a chart.
We don't see the point.
Oh, I see. Yeah, sorry. There you go. So we create an instance of a chart, and then we call the D3 chart, and we call create here, and then on update, we call update, and then when we unmount, we just destroy it. We are also using the ref, and we create the component, the container with React as well. Then when we go into the D3 line, this is basically a simple object that has 3 methods. And inside, we will put our D3 code so that we create, update, or destroy the chart. And regarding pros and cons, I think it's super easy to integrate D3 code with this way, because you're just going to put that D3 code on the D3, on the chart file, and that's where it's going to be. It's going to be a really sharp separation between D3 code and React code. Still, I think it's going to be flexible because you can encapsulate any kind of chart. Usually, they all have the same methods. So, and the same kind of wrapper is going to be, you can use it with different charts, and it's going to look a lot similar. And one thing that could be a problem is that you will need to add an extra file. For me, it's actually not a problem. And also, maybe you think that it's not that React idiomatic, and it makes sense, but at least there's a big separation, so it's not everything on the same file, like a crazy thing. Cool. The last approach is React D3 for the math and React for the DOM. And this approach is more leaning towards the React side. Here we will use D3 to compute paths and to do all the math necessary to draw the SVG elements. And then React will do what it does best, that is rendering the DOM on an efficient way. This strategy is based on the amount of D3 modules that don't actually use the DOM. So we have all these modules that are different repos, are part of D3, and they don't really use the DOM. So we can use them in our application. And then for these modules, these are the ones that we select, we use on the DOM. So we have selections, so that we will use React. It's going to be rendering on the React way, and that's not a problem. On transitions, that's our animation. So we will use a React animation library, wherever you need. They're mostly kind of the same, but there are things that D3 can do, like interpolate paths on SVG, that the React animations won't be able to do, but most of the time it's going to be fine. Then the axes, we'll need to do them again. Sometimes that's okay. It's a little bit of grunt work, but it's okay. But the problem is going to come with this, with zooming, dragging, brushes, geo, and shapes. So we will need to do by ourselves all those pieces. Let's see how it looks on the code. So this is a super simple chart. We will have, so in the render, we have an SVG with the width and height that we set from props, and then we call this drawLine method. And the drawLine method, we're going to create scales. That is something that we need for D3 charts. And then we're going to create a line that is basically the path that we're going to use to create a line. Then see, yeah, here we get the line, and we pass in the, oh, sorry. Yeah, so we have the SVG, and then we have the path, and then we have the scales and the line. So this is going to give us the path for the SVG that we're going to use here, passing the data as the input. Okay, so really good thing for this approach is that it feels super great to build charts with it. It's like just working with React, so it's super fluid, super nice. It feels really great using it. And it could get into a well-crafted code, but it will take a lot of work up front. Also, the axes, brushes, the zoom, you will need to re-implement them again. Another limitation is that when you want to move into Canvas, then you will need to, I don't know if you can do it, basically. So to put some context here is that usually when you are building a D3 chart, if it's not too big or it doesn't have many elements, you will do it on SVG. But when you get into a problem where you have a lot of DOM elements, you're going to get into a moment that you cannot do it on SVG. Or you can do it, but it will perform really badly. So what we do is we move into Canvas. And then there's another threshold where Canvas is not enough. And then you will need to move into WebGL, right? Oops. So with this approach, using React, you are limited to SVG. So if you get into the problem of having too many elements, you won't be able to get out of there. Cool. So here we see all these approaches according to the level of integration with both React and D3. Cool. And now that we saw the different possible approaches, we'll review some libraries that combine both React and D3. And we can analyzing the ecosystem, I have observed that, first, a good amount of non-maintained libraries. And this is because React and D3, they keep on getting updates all the time. And it's really not easy to keep up with them. So if it's already hard to keep up with just one of them, having a library that combines both is kind of a lot of work. Also, on the D3 side, the D3 version 4 brought a cleanup on the field because there was a lot of libraries that couldn't update, or maybe they didn't have the horsepower in order to update all their charts into version 4. So there's a good bunch of libraries that they got basically abandoned. Also, what we're going to see now, they differ a lot on the abstraction levels. Let's going to see some of them, and I'm going to show some code, but don't worry if you don't see it on detail. What I really want you to see is kind of the level or the shape of the code and the level of abstraction. The first library I want to talk about is Victory.js. And it's a library that rewrites a good chunk of D3. This is one of D3 for math, React for the DOM. And the level of abstraction of Victory is kind of low to medium. And this is how it looks, a line chart. So we have kind of a couple of axes, a line, 2 lines, and we have a chart kind of like the container. Victory is easy to get started with, and it features a nice playground and really nice docs. It also includes Zoom and Voronoi, so 2 components that are not that usual, and that can be really handy. And this is the only library that can be used on React Native. So if you are focusing on React Native, probably this is the only library that allows you to create charts on React Native. One of my favorite libraries is Recharts. It is aesthetically really polished, and it has a great tooltip. Its code is a little bit more abstracted than Victory.js. Here we have a line chart, couple of axes, a grid, tooltip, legend, line. And it's kind of more high level and kind of a little bit more magical. Then it has a really good test suite, and apart from graph, legends, tooltip, and brush, they're all pretty polished. They are really good quality components. Then it also has good docs. And one of the latest libraries is Nivo. Its API is a little bit different because it is a really high-level library. So every chart on Nivo is a different element, and when you render them, it's just one element. You pass all these options, and then it renders your chart. It is the only project that offers many rendering options. So you can have SVG, Canvas, and they have an API for rendering HTML. So you can use it as a server-side rendering, or even you can add it to emails. It uses React Motion, and it has docs that are really good, really nice. It has a lot of interactive things, so you can change things on the side, and then you will see how it looks like. Then a library that is absolutely the opposite of Nivo is VX. That was created in Airbnb, and it's a really low-level visualization components library. Well, I wouldn't say even library, I would call it collection. And it's super flexible and powerful because, and actually the approach is that you could actually build your library using VX. So I think about it like it's React for D3. Sorry, D3 for React. Here we see some of that code. We have an SVG, a rect, a group, and a line path. So all this code, you're going to see it, I have a demo. This is just a line. There's no axis, there's nothing. And it's pretty big. So as I mentioned, it's kind of D3 for React. So it's really low level, but on React. And then the good thing is that it's really flexible about the animation library. You can use whatever you want. And because it's so low level, it's super powerful. But it's also a little bit complicated to set up. So if you want something that is just drop it and use it, this is just the opposite. Lastly, we have Brightcharts React that we created at Eventbrite as well, and it's still in beta. This is the only library that uses the lifecycle methods mapping approach. And it allows to use sprite charts in React applications through a simple wrapper. In this case, sprite charts is still the main library. And when we use this wrapper to work with it on React. We also have other wrappers for Angular that some people in the community created, and we are planning to do something for Vue as well. Because at the end of the day, it's super easy because we have those chart wrappers. We can just put this on different libraries, and it's going to work. The code abstraction level is a little bit, it's kind of high. Here you see this is a line chart with a tooltip. So we're using render props to render the line. And kind of, yeah, the abstraction level is kind of mid-high, I would say. I can really be objective about Righteous React. I would say, oh, this is the best, but it's, well, probably not. A good thing, one thing that Righteous React doesn't support is server-side rendering. But what we do is we provide some loading states, like a kind of a skeleton loading states. So you can put that in the meantime. And if you want to explore more of these libraries and others, I created this demo. It's kind of a small demo page with some of these libraries. So here's Victory, Richard. So here, check this. This tooltip, this is my favorite part of Richard. It's pretty smooth. And we have Nivo and VX. So this is the code that we were seeing before. It's just doing one line. It's really low level. And then here, this is Righteous React. And then this is Uber's visualization library. Okay. Oops. Cool. Also, I've created this comparative of D3 and React libraries. It took me, oh, sorry. I probably need to update URL. So that one is good. OK. So what I did here is a spreadsheet with all the libraries. And I have a script that is grabbing information from all these GitHub repositories. And then we have things like number of stars, number of forks, description, size, open issues, stuff like that. Run it every once in a while. I run the script again and update it. And so these are the D3 libraries, and then we have D3 and React libraries. So some of these kind of terms are really subjective. It's like, well, there are things that are not subjective, like if it's updated to before or not. But if it's active or not, it's kind of, well, I'm just trying to guess. So please take it with a grain of salt. And, well, the idea is that it will help you kind of come up with a decision if you choose to use a library. Cool. So we are close to the end of this talk. And I would love to give you a general vision of what you can do with all this information. Because as many times what we as developers need is just to make a decision and choose a strategy to get our projects done. And these selections or these processes, they are not made in the void. So we will be choosing, you will be choosing, depending on the context of your project, maybe the history, and the resources that you have. And there are so many variables. I think we are mentioning cost, scope, time, and quality. So maybe there are too many. So as a good engineer, I'm going to simplify this by fixing quality. So we're going to talk about well-tested D3 on version 4 and with great docs. So and the next criteria is time. So I will ask myself, it's going to be a long-term investment. If that's the case, I will advise you to roll your own D3 library and then wrap it with React somehow. The way it doesn't matter. The problem is that libraries don't assert you to have 5 years of life. So probably if it's a long-term investment, it's better that you create your own. But if it needs to be done as soon as possible, then I will go and try to find the library that gets closest to your specs, and then maybe fork it or contribute back to it so that you can get that done pretty easy. If you think about the scope, if you ask yourself if it's if you need just basic charts, then I would say go to the closest library to your specs. But if it's a single and complex piece, unless it is a library, there is a library out of the box that just covers what you need, I will go with regular D3, and then maybe do D3 within React. If what you need is something highly customized, so maybe you have a UX designer or a product owner that is going to ask for something super specific about for your charts, I will tell you just roll your own D3 library, or maybe fork another library and customize it. And lastly, thinking about the money, this is always kind of more tending about the skills of your team. So if you have a lot of D3 developers, then a clear separation between D3 and React is probably something that they will like. So maybe lifecycle methods or the Photon would be a good approach. If you have, on the contrary, a lot of React developers, then React D3 libraries will probably be more appealing. Or maybe lifecycle methods using D3 examples as a base. What I really don't recommend is to create your own D3 for math and React for the DOM library. It takes a lot of work. It's a lot of work, and unless you have a lot of time and it's going to be a long-term investment, it probably won't make a lot of sense. In summary, React and D3 can definitely work together, and we can choose where to draw the line between them. They are in constant evolution, so libraries combining both libraries will have a hard time keeping up. Also, it's really hard to decide how to approach this problem. There's a lot of options, but choosing depends on so many variables that I cannot really give you hard rules about anything of this. But at least I hope I can help you with this decision, with this talk and the resources. Thank you for listening. So I think we have some minutes to talk to questions. Yes, please.
Maybe you have any suggestion if we have a real-time feed of data, like RxJS or WebSocket feeding data into. Do you have any suggestion on what is the preferred way to go through, or if you have any experience before on this?
So the question is about if it's a real-time chart. In theory, it shouldn't matter. So D3 from the beginning was created in order to allow for real-time data, and kind of the kind of data joins and all these enter, exit, and update pattern allows to do that. So when you got things that they go out, you can do whatever you want. You can animate it out or in. And when you wrap it with D3, with React, then it's probably going to work the same way. So I really don't think it's a factor that influences the decision for this. So whatever you prefer. Yeah, another question there?
So based on the initial demo, does that mean that something as interactive as that is essentially impossible in React at the moment with the current libraries?
Like which one, sorry?
The bubble chart.
Oh, the bubble chart. So, yeah, sorry, the question is if we will be able to create something like that bubble chart with React right now, with the libraries that we have. Yeah, probably not. That is a kind of an example of a one-off, really specific chart. So no, I would say no. So if I had to do something like that, then I will do it with React, with D3 right away, and then I will just copy paste it, or maybe put it in a facade with the mapping kind of strategy. But no, I wouldn't try to do it with React. And if you try to do it with React and D3, oh my God, that can be super crazy. Because also the good thing of that bubble chart is that those animations, right? So you will lose all that, and you will need to do that with React animations. I don't know how that will work. Probably a little bit tricky, because that's a force layout. It has a force layout, so it has this gravity kind of thing, and it's really nice. But yeah, probably D3 only. Questions? Ale?
That project you have some simple charts, but you also have some more complex animations in there. I think that tends to go like two different routes at the same time. So like use a library for the simple charts, but like some kind of more native 2D3 for the more complex stuff, or it's just going to be nightmare managing everything.
Yes. Yeah. So yeah, the question is if you have a long-term project that is gonna have all kind of charts, complex and not that complex, how you would go with that? Yeah. Yeah, I would say creating your own D3 library will make sense, especially if these charts are kind of a big component of your product. Then just go for that, or maybe just check out the list of D3 libraries and see if there is one. And I wouldn't tell you, okay, go and see if they have something similar to what we have, to what you have. It's more about the API and the way that they work with it. I will go more into the code because you will be working a lot in that one. If you fork it and you create your own on top of it, it's more important not that they have what you needed, but they actually follow a code path or a kind of quality that you are looking for. I think that would be more important. But in general, yeah, a new D3 library or a fork of an existing one, I think would be better. No more questions? Well, thank you all for coming.